Initially, I prepared a talk for which lasts about 10 minutes, so we have plenty of times for questions and stuff. You're going to see a short demo, but first of all, let me introduce myself also. So my name is Roman. I'm the founder of Triscon IT Services. We currently work for one of our customers, IT Ergo, or Ergo in Düsseldorf. This is my colleague Fabian, who will assist me with the demo part. We specialized in performance and load testing as well as test automation. It's also a part of our portfolio, a little bit of software engineering. So both Fabian and I, we have 10 years experience as software engineers, and right now 80% what we do is actually just performance and load testing. Today we already heard a lot. Oh, let me also mention our company is about 2 years old. We're doing performance and load testing before already, and this year we became a Neoload certified service partner, and it fits in very well today what we're going to show you, because all we have heard so far is actually about automation. If you think about it, each talk it was about automation. It was automating the pipelines, the execution part, automating even the analysis part, as we heard the interesting talk about Dynatrace, and with the AI part, which does all the job for you, or most of it. And so what's actually missing, the missing piece, is what I'm going to show you. It's that what's necessary, like before you can do all this, is actually having scripts. It's the most painful part of a performance engineer, to maintain the scripts, to actually click through the applications, to update the scripts, go through it over and over again if you regularly test applications. And we try to address this problem. Of course, there's some solutions out there, and I'm going to show you how we approach this with Neoload and Selenium. So this doesn't work, so maybe you have to, maybe too far. So basically, this is sort of the agenda, what I want you to tell. It's about how the automated script generation works, how it looks like. That's the demo part. And the cool thing is that we use the same scripts for generating Neoload scripts and perform load tests. We also use those in functional tests. So there is a link between the functional test team and our performance load test team. And the scripts are only maintained once, and we have double usage. And how does this all work from a technical perspective? I'm going to go into details a little bit about that, and of course talk about the benefits. And now let's really deep dive into it. So the demo part will start now. Let's just see the next slide. What I'm going to show you now is a sample test case. This is actually just lines of code representing one test case as we run it in functional tests, and also can use it in load tests. What you need to be aware of right now is just the size. So it's just 10 lines of code, which in fact represent some sort of Selenium operations in the background. And if we execute this test case, that's what we are going to see now, what it actually does. And then I'm going to talk a little bit of how this is actually intended to use. So now Fabian is going to actually prepare the demo. You can start already. So what we did was actually not just Selenium. I don't know, let's do a little survey. So who of you has experience with just Selenium, not only Selenium and Neoload, but Selenium? And who of you have already, just keep your hands up, and who of you have also dealt with the Selenium Neoload wrapper? All right, so a couple of hands, of course you have, because Marcin actually introduced it to me 2 years ago. And what we did, anyone, why I'm asking, anyone who has dealt with Selenium before knows that it can be quite painful, because Selenium doesn't know when the browser has finished loading your web page. So if you say, this is my test action, click here, click there, fill there, whatever. If you just fire it through without intelligent wait constructs, so telling to wait until the actual page is really loaded, your script simply breaks. And if you don't address this problem, you have another thing to maintain, and it can be really painful. So what we did is we encapsulated this whole Selenium stuff into a framework. So if you script in our approach with Selenium, you actually just say, click here, fill there, and whatever, call this page, and the whole Selenium stuff is encapsulated in the framework. So we tried to make it as stable as possible, and we provided it as a NuGet package, ergo side, so actually developers and feature teams can use it. So they can script with it and use it in functional tests, and later on we can actually generate load tests out of these functional tests. So that was the whole purpose. What we see here is, of course, if you do this kind of approach, you have a little bit of configuration. And we can say we support different types of browsers. Now we are doing just the Selenium part without any neoload involved, and then we're going to see the other part. So we have a configuration saying we run a test now, the one I showed you in Selenium and with Internet Explorer, and we just fire it and see what happens. And hopefully, because this is a live demo with internet going over from my mobile phone from a basement, so let's see how it works. So what happens now is actually this is plain C# code executed in the background, and the web page is called here. It is just a standard common web appearance of ergo, so nothing confidential, where you can actually calculate the tariff, and this is where the sample ends. And so this is actually the steps that each of us, all of the performance engineers, has to do over and over again to maintain the scripts, or even to generate it. Now it was simply executed. We see green light, everything worked fine without neoload. So this is the functional test perspective. So if I'm a developer, I don't care about neoload. But now I say I have this test case, I have it checked into some sort of collaboration, and the project comes to the part where they say, okay, now load testing becomes interesting. And we have about 50 test cases scripted already. Let's talk about the most important business cases. So we do some sort of kickoff, and we say, okay, we're going to use these 3 or these 5 cases in a load test. What we do is we get the scripts from the developers and plug in here just a switch. We now say neoload, and the same scripts. In this case, we didn't even write. Of course, we write them also if we perform them or create scripts. We do this the same way, but this can also be done from the feature team, and then we just plug in neoload here. So what happens behind in the framework is now the Selenium WebDriver technically simply gets replaced by the neoload Selenium wrapper, which is basically the same. And from the test design part, nothing changes. It's just configuration stuff. So we can now do the same, and now for doing another configuration change now with Chrome. But by the way, I'm not trying to sell anything, so we're just passionate about it. If you're interested in how it works, we of course can talk about that. So, yeah, you can start the test now, and now we see what happens. Of course, the same thing will be now done in Chrome. And in the background, neoload is of course already listening. This is what I'm talking about. This site now really was initially loading slow, and then it's fast again. And if you mess up your weight constructs in Selenium, it might try to click too fast and your script breaks. So what we see here now is most of the people here know it already, the post-recording wizard of neoload. And now we see here that we have a test case created, which exactly represents what we just saw in the browser. And this doesn't only work for creation, we also use it to maintain our scripts. And every time I talk about this, I get asked, how good does it work, the maintaining part? And we heard this quite a lot already, but it really works, I have to say, like a charm. I don't know how you guys did it. Updating the scripts really works very well. I can assure from my experience, it works in 90% of the cases. All the correlations stay there. Of course, if you have major changes in the business case, of course you have to do something there. But going even from beyond the 90%, what we experienced, it's pretty cool to use the neoload frameworks in addition. So you once define the near-load frameworks here in the controller to actually do the correlation as automated as possible. And if you then update your scripts with Selenium and something is still missing, there's a high chance that it's similar to what you have already correlated before. Let's say if we have just one additional form in the business process, the chances are quite high that your framework automation just catches this and you get even a better automation quality. So that's, so to say, to catch the rest of the 10% that are left if Neolode doesn't like fully manage to keep all the correlations. You will never reach 100%, of course. I would never say that, yeah, but you can get close to with this. That's our experience. And now maybe let's go back to the presentation. So what does it look like? By saying, I tried maybe even try to zoom in on the code part. So by saying encapsulating, we thought, and this is what I want to like, the advice that I want to give you. If you're trying in a big company to work with Selenium, try to avoid everyone approach or finding their own solution of dealing with Selenium and weight patterns or whatever. Try to have a common solution. We thought about what can be done in the browser. You can click something, so we made a click action. You can fill something, so there's a fill action, or you can call a URL. It's quite limited what you actually can do in front of the PC, of course. So each line of code here represents one action we just saw in the test case. First of all, it's just calling the site. Then we plug in something in the search field, and the framework really frames you. So the part is here that you cannot access any Selenium operations. You can't just say, now I want to do this, because this is the design part. It just populates a list of objects, which is then executed in the run part. So you can't address any Selenium driver here. But what the framework does is it forces you to define, and it forces the developers to give a name to their test actions, so to say the transactions. Of course, if we get test cases from developers, we need to go through this and adapt the transaction names to our standards and stuff like that. So that's still something we do after that. But one thing is give it a name, and of course you need a target, and the most simple thing to do is targeting an element with XPath, so which is simple passing the HTML document you get in the browser and saying, okay, my element I want to click is the button that contains the text los or go, and that's all you need to actually represent one test action, which is not much information if you think about it. It's just this piece representing the whole page navigation. I'm going to go into detail about that. And the third thing is the framework forces you to give a short description, just text description, what just happened. So you just say, click on this icon or whatever. And so here we have the different clicks and fills, and if we execute it, the Selenium driver we address, or Neolode driver does the rest for us. So how does this look like? Let's go to the next slide. Here we see one test action, which we just saw in Neolode. So this is the test action. It says ergo de 030. It's the same here. And this is where the benefit is visible in terms of quantity. If you have a new release, it's very likely that this script is going to break because one simple ID has changed. And here, in this approach, we're on the browser level. This is protocol level. Neolode can only operate on the protocol level. It's not the fault of Neolode. It's just a different level. Here we're in the browser world, here in the HTTP protocol world. And this script will work as soon as it finds the button go. And if there are 3 more additional input fields there, or whatever, which are not mandatory, the script will still run through. That's the benefit. The lower script, the Neolode script, will break, of course, and you have to re-record it. So this actually works, and I highly recommend that you use either for test automation Selenium or RunnerX or anything else. And this is really one of the main reasons why we like Neolode so much. because it really saves us a lot of time in terms of scripting. And just not to go to get carried away and run out of time still, so let's go to the next slide. So the cool thing is, as I mentioned, we don't use our scripts only for like maintaining our load test scripts. Other people use it as well. And now we can actually, maybe since we have time, not only look at the pictures, just go into the system and see what IT ergo people who are not us, who are not the load test team, are doing with these test cases. So basically, they're using it to warm up their systems, to do shakedown tests, to do stability checks, and stuff like that. And this is where we have a beautiful communication channel now between us, the load test team, neoload and stuff, and the functional testers. So since they are using our scripts as well in shakedown tests, we really get the information very, very early in the development if something changes. So it's like a seamless flow here. Here we see how did we automate this. So this is all Microsoft based here, so in the Team Foundation server. And Selenium, people who know Selenium know there is Selenium Grid. You can populate some agents who run the tests for you. We here have a different approach. This is from Team Foundation server, so the test is actually executed on the Microsoft test agent. And you can run the script in different stages and see how it performed. This is actually done overnight in different stages. So if you go to your work in the morning, you already see how what test cases worked and what didn't work. And now let's just look into a sample where we see here, okay, in this stage called FIAT, it's something in the middle between dev and prod. So we have 50% test cases that worked. Here we only see those who failed. This is just to give you an idea of how the test automation stuff can look like if you use Team Foundation server. And here we see it was executed quite some time, so you have some sort of history, and you see when it worked with what build and when it stopped working. And now let's see, okay, how can we identify a problem? So we click on the test and we actually see how far it got. We take simply a screenshot if in the error case to see if something changed we didn't expect in the script or if there's an actual error. So this is how we become aware of changes in our load test scripts necessary to perform load tests after development is finished, because they're using it in functional tests. We can see, oh, okay, there's a change. It was already in the first stage, even if we test in pre-prod, so quite late. We're trying to shift left, but there's some walls. So we actually become really early aware of what we need to change in our scripts. And here we see each steps we just named and described, because we forced the people to do it. We see what it actually performed and what time and which operation failed. Then you have the screenshot and the link to the log files as well, to the application logs. So you can very fast tell what went wrong, if the script is broken or if it's the application itself. And since we do this because, of course, it was a demand. We were quite often asked, can we use your scripts, because you have important business cases scripted already. Can we use it in shakedown tests? And I have to say no. No, you can't use load test scripts in shakedown tests. You need a lot of students to maintain the scripts, of course, because every minor change in the post request will break a script. And so we tried to shift it to a different level and also address the problem of automating our whole design process as much as possible. And one other thing that is quite boring is documentation. So we thought, okay, we can do screenshots, and this is something that I would recommend you as well. If you use any sort of test design automation, whether be it Selenium or anything else, you can simply take screenshots of what you're doing. And if you if you script your test cases the way that you say, okay, I give it a name and a description, and the possibility to take screenshots, you have it anyway. So what we do is we have automated test case documentation. So if we script something, we don't need to document it. We just say, okay, now generate documentation. It's just another switch in the configuration. And if we make changes to our test case, because there's additional step, we don't even manage not to have documentation for it because it's just the same. It's all in one place. So here we see just what we saw so far. It's all comes from the single line of code where we just say test step name, description, and then it just takes what it sees during the execution and creates a PDF out of it. This is really simple to compute actually. And all right, now I really talked a lot. Let's go back to the presentation part. So I assume there will be some questions, so let's just speed up a little bit. So the process actually here was intended that we provide some central way how we do the test automation that can be used for others with Selenium. So people at IT Ergo have the possibility to just pull the NuGet package, which is just a framework, and a sample, and they can start scripting without the knowledge of Neoload. And later on in the process, if we say now it becomes interesting, we need a load test. Someone said we need to do performance tests. Then they do a kickoff with us, and we can say, okay, what test cases do you have already? And so we just select a subset of it, and then we simply continue with the usual process. We adapt a few namings and stuff like that, but then it's just design, correlation, and anything that comes anyway. So to sum it up on the next page, what we gained from this approach. The test cases that we need in load tests are of course available sometimes already, so we only need to make adaptations. It can be designed early on, and we have this additional communication between the teams since we also kind of are the people to talk to about how to use the framework and stuff, so we know what's going on in the individual teams. And we have a two-way usage. We use it in functional tests and Selenium, with Selenium, and in Neoload, actually it's a three-way usage. I don't know if anyone has tried this so far. Sometimes we had the requirements to actually measure client-side, so means browser differences. And Neoload is pretty cool because you can not only run in design mode, but even in end-user experience mode. So you can use the same scripts to run parallel to your load tests to actually measure the exact time that it takes in browsers. So this is how we tested different behaviors in Internet Explorer and Firefox, for instance. And of course, we talked about the documentation part, and the cool thing here is that we really were able to encapsulate all the nasty Selenium stuff away, so you don't need to worry about all these things that can break your scripts. So this is after a couple of iterations it took. I think we managed here to provide a quite stable solution. And I can only recommend for if you have a lot of test cases that are executed again and again, I can only recommend some sort of approach. We really made great experiences with it. And first of all, now let me thank you. Thanks for letting me talk here. And then we can be up to some questions, of course. Thanks.